Hi, everyone. I just wanted to take a couple minutes to talk about how to do absolute value inequality word problems. So hopefully this will cover everything that you need to know. I'm going to go over two different examples that kind of cover both ends of the possibilities of what you could get in a word problem. So I hope this helps. Let's start with the first one. Alessandra is raising turtles and must keep the air temperature in their enclosure at 21 degrees Celsius with a relative error of less than 2%. Write an absolute value inequality for the actual temperature and then find the interval in which the actual temperature must lie. All right. So this is a very common kind of example of what you're going to get with an absolute value inequality word problem. Basically, you're given your target, and then you're given an error, and we're saying that the error can be at most 2% over or at most 2% under. Anything more than that and we're having a problem. So we can already see right there we have a range of values. So again, to get the range you need an and that results in a less than. We're specifically dealing with less than. It even explicitly says less than. So we're just dealing with less than, not less than or equal to. I'm assuming, I don't know enough about the biology of turtles, but I guess at that point, there's a problem. So let's look at what we're dealing with. So we're looking at the actual temperature, and I'm saying that my real temperature, whatever it is, I don't know what it is, has to be within this range. All right, so again, we're setting this up the same way we were setting it up in terms of the absolute value equation problems. We're dealing with, here's our actual, here's our target or our goal, goal slash target. And then outside here, we're given our margin of error. So this is essentially, again, when we were doing this, x minus 21. That is, the difference between the actual and our goal. And as long as the difference between our actual and our goal is less than the 2% error, we're fine, okay? And 2% of 21 is 0.42, okay? So you can figure that out relatively easily with either a calculator or knowing that, you're essentially just moving the decimal place over twice and then doubling it. All right, so anyway, again, we set this up. This is our margin of error. Our error out here. And we're saying as long as my error is less than the 0.42. So the difference between my actual and my goal has to just be less than this 0.42. And as long as it is, we're fine. It doesn't matter if it's over, it doesn't matter if it's under. I'm just saying I am measuring the actual temperature. And as long as it is within 0.42 degrees Celsius of 21 degrees Celsius, it's fine for our turtles. We're doing everything in our power to keep our turtles safe. So that's why we need to make sure we know absolute value inequality word problem knowledge. Keep turtles safe. Hashtag save the turtles. All right, moving on. So let's actually figure out what the interval on this is. So we have our inequality here. And now we're going to actually solve it. So again, we have less than and. So we already know this is going to be an and. You could write it in one of two ways. You could write it as x minus 21 is less than 0.42, which is less than negative 0.42. Alternatively, you could write it as two separate ones. The x minus 21 is less than 0.42, and the x minus 21 is greater than negative 0.42. Either of those would have been acceptable. I usually just do it this way because it's easier in my head. So then we'll add the 21 to both sides, add the 21 to both sides. or all sides, I should say. All right, so we'll do 21 minus 0.42, which should be 20.58, less than x, which is less than 21.42. So we're saying as long as the temperature within my turtle habitat slash enclosure, whatever we're keeping our turtles in, has to be within this range right here of 20.58 degrees Celsius and 21.42 degrees Celsius, which may not seem like a whole lot, but that's just because we're not necessarily used to dealing with Celsius. That is a sizable change. So just wanted to give a heads up on that. So let's look at our next problem. So I'm just gonna leave that out. Two of the most expensive cars in the world are car A and car B. Ooh, we can call them whatever we want. Okay. I don't know anything about cars, so we're leaving them as car A and car B. The prices of these two cars differ by more than $12,000. The price of the car A is $130,545. Assuming we don't know which model is more expensive, write an absolute value inequality that describes the situation. So as I said, we're dealing with two different types of inequalities here. We're dealt with a less than, which was the and now, as you could probably have guessed, we're going to be dealing with an or, which will be the greater than. All right. So we know that the prices of the two cars differ by more than $12,000. All right. And we also know the price of car A. So I know if I took the difference between car B and car A, my difference would have to be greater than $12,000. So again, we're going to do the same sort of setup that we did before. The absolute value of our actual measurement, right? It's a little bit weird to say this is, now the goal, so to speak, because we know that they're different, but you can kind of think of it as, the standard that we're measuring it against, or the information we already know, right? So the minus the 135.45, and we're saying that that is greater than, because it differs by more than $12,000. I don't know how much more. All I'm saying is, since again, I don't know which one's bigger, I'm just saying the difference in their price has to be at least $12,000. So B could be less expensive and be $12,000 less, or more than $12,000 less, or B could be more expensive and be more than $12,000 more. All right. So again, rate or than or. So we are going to set this up as an or. So X minus 130,545 is greater than 12,000. So just as we always had. Or X minus 130,545 is less than negative 12,000. Oops, I ran out of room. So now we'll just solve this. So we'll add the 130,545 to both sides on both of these. And we will ultimately get that this is 142,545. So we're saying that on this side, what we're saying is that the price of car B could be greater than 142,545, which I don't know anything about cars, but that's very expensive. Or we're saying that it could be less than 118,545, which is still very expensive. Obviously, in a real world scenario, we knew if this was actually less than 18,545, obviously there'd be another kind of like stopping point, because at a certain point it has to be above the third most expensive car. Obviously, on this side, we just know it's more. Realistically speaking, I don't know how much more. Odds are it's probably not $100,000 more, but it could be. We don't know yet. So anyway, what we're given here is we are determining that either the price of car B is greater than $142,545 or it is less than $118,545. Both of which are exorbitant amount of money I would not want to pay for really either car, but that's not where I intend on spending money. So anyway, please let me know if you have any additional questions. I hope this is helpful and have a great day.